This is a video showing you how to sketch the graphs of quadratics and then how to use that sketch to help you solve quadratic inequalities. So the graph of a quadratic would always be a parabola, which is a really useful engineering and scientific shape. It has all kinds of useful properties. Just like with the quadratic formula, we'll talk about a, b and c as the three numbers in the quadratic: the number of x squareds, the number of x's, and the number on its end. The easiest place on the quadratic graph to find to start with is the y-axis intercept, because just like with the straight line equation, where it's y equals mx plus c, here it's also the plus c, the number on the end of the equation, that tells us where it crosses the y-axis. So straight away we will know where it crosses the y-axis. Then if we move to the two x-axis intercepts, which are sometimes called the roots, we find these by solving the quadratic. That's what you've been doing when you've been solving quadratics, finding the two roots. Now you can solve the quadratic in a variety of ways. You can factorize it, or you can use the quadratic formula. But however you choose to solve this quadratic, whichever way is simplest to you, the two results that you get will tell you the x-axis intercepts. And then the final one of the four key points is the turning point down here, which is sometimes called the vertex, which is the mathematical name for turning point. The vertex, because one of the properties of parabola is that it's symmetrical, the vertex is in the middle of the two roots. So one way of finding it is just to average the two roots, and that will tell you the x value of the vertex. Sometimes this is called the line of symmetry of the parabola. It's the same thing, it's in the middle. Okay. Another way of finding the x value here is to use this little equation minus b over 2a, which if you look carefully at the quadratic formula you might be able to see is the first part of the quadratic formula. So if I take minus the number of x's divided by 2 times the number of x squareds, that's another way of finding the x value of the middle of the graph here. And if I know what the x value is, I can put it back into the equation and use that to work out what the y value is there. So that's how I can sketch my quadratic graph. If the quadratic has a negative number of x squareds, the only thing that will change is that instead of a U shape we get an N shape. And now what we do is we use these graphs to solve quadratic inequalities. So everything you've dealt with at the moment has been a quadratic equality, a quadratic equation. The quadratic is equal to 0. But if we change that, for example, we make the quadratic greater than 0, then we've got to find a new way of solving that. So when the quadratic is greater than 0, it means we're looking for the bit of the graph which is above the x-axis, because the x-axis is where it's equal to 0. And when the quadratic is less than 0, it means we're looking for the bit of the graph which is below the axis. So depending upon which way up the graph is and which part you're looking to find, you may be looking for one single stretch of values, or you may be looking for two separate stretches of values, and that should influence how you write your answer. For example, if we had to solve this one, so we want to solve this quadratic inequality. So I start by sketching the graph. So I've got plus 12 on the end of it, so I know that's where it crosses the y-axis. I solve the equation. I've chosen to solve it by factorizing, so I know that's where it crosses the x-axis. So it crosses at -6 and -2. it's got a positive number of x squared, so it will be a U shape, and halfway between -6 and -2 is -4, so that's where the vertex will be. So that tells me everything I need to know about the graph of the quadratic. Now I just remember that because I'm looking for the quadratic to be greater than 0, I'm looking for the bit that's above the axis. So I'm looking for this bit here and this bit here. So it's two separate regions in this case. This part of the graph is the part of the graph with x values that are smaller than -6. So there's the part of the answer that represents that part of the solution. And this part of the graph is where x values are greater than -2, because it intersects the x-axis at -2, so for any x values bigger than -2, it's above the x-axis. So that's the part of the solution that represents that part of the graph. Have a go at this one. It's very similar to the last one. Pause the video here and then I'll show you the answer. Okay, so the same as before, we know that the y-axis intercept will be +4, and we can solve this equation either using the quadratic formula or factorising to find the x-axis intercepts. I've factorised it, so my graph has looked like that. Crossing the x-axis at 1 and 4, crossing the y-axis at 4, so it looks like that, and the vertex is at 2.5. The question is saying when is it less than or equal to 0. So it's equal to 0 at 1 and 4 here, where it touches the x-axis, and it's less than 0 when it's below the axis, so that's this single region here. So I'm going to give the answer as a single answer. So up here there were two separate regions, so I gave two separate answers. Here there's one single region, so I give it as one single answer, and that's the region between 1 and 4. So I write it like this: x values smaller than or equal to 4 and bigger than or equal to 1. Try the next example, pause the video. It should have looked like this. You should be able to sketch the graph in the same way as we've done 3 times now. And we're looking for the part where the graph is below the axis, so that's similar to the last question. Apart from it's got to be less than and not less than or equal to this time, so you see the slight difference in the signs. So I'm looking for this region of the graph, which goes from -2 up to +1. So it's from -2 to +1, not including those values, and it's a single region. Pause the video, try the fourth example. Okay, and here's the fourth example. Crossing at -4 on the y-axis, having a U shape because it's a positive number of x squareds, crossing at 4 and -1 on the x-axis, so it looks like that. We're looking for where it's greater than or equal to 0. So that's this region and this region, two separate regions, so two separate parts of the answer. Here it goes above the axis at -1, and we're going that way, so we're looking for numbers less than -1. Here it goes above the axis at +4 and stays above the axis as we move this way, so that's x values greater than +4. Now there is a small error in the answer to this question. I'll give you a second to see if you can find it. And my answer really should have been less than or equal to -1, because I'm asked for when is it greater than or equal to 0. So it should have been less than or equal to -1 and greater than or equal to 4. So that's quadratic inequalities, and sketching quadratics. Now you should be able to do the worksheet.